We know that we define acidic solutions as having H plus and basic solutions as having OH minus. But does water have H plus and OH minus in it? Or is water just H2O and that's it? That's what we'll look at in this video. Now we're going to look at pure water when nothing is added. It's found that two waters react with each other, where one of the waters takes the hydrogen off of the other, and what it forms is a hydronium ion, which we call an acid, and a hydroxide ion, which we call a base. When we do this, we make both one hydronium and one hydroxide ion. We can simplify that as water forming the hydrogen ion and the hydroxide ion. Notice that the simplified equation uses just one water, the hydrogen from the hydronium, and the hydroxide ion. The hydronium is the only way that we find acid in water. We do not find it as the small hydrogen ion. Now we're going to look at how much water ionizes in pure water. It is a very small amount, about 1 in 10 million. It ends up that this is now 10 to the negative 7, and so we can write that as 1 times 10 to the negative 7, or just 10 to the negative 7 to keep it simple. Since we know the hydronium ion, and we know that every time water breaks, it makes one hydronium and one hydroxide in a 1-to-1 ratio, we know that there are 1 in every 10 million waters break into hydrogen and hydroxide. That is written as 1 times 10 to the negative 7 again, and our molarity of hydroxide is 1 times 10 to the negative 7, or just 10 to the negative 7. Whenever we are in pure water, it's known that the hydrogen ion times the hydroxide ion is always equal to 10 to the negative 14. This is done by adding the exponents. That means that hydrogen times hydroxide is always 10 to the negative 14 when there's water. Now we'll rewrite it over here, and we'll be solving this problem for if I give you the hydroxide ion concentration of 10 to the negative 4, can you find the hydrogen ion concentration? You'll need to divide both sides by the hydroxide concentration, which in this case is 10 to the negative 4. And that is just 10 to the negative 10, because when we do division of exponents, we really just subtract those two exponents. In this case, negative 14 minus negative 4, which is negative 10. So far, we've been talking about pure water. We're now going to look at some solutions or mixtures. Specifically, we're going to look at aqueous solutions. An aqueous solution is something that is dissolved in water. We're going to look first at neutral solutions. A neutral solution is when both the hydrogen and the hydroxide ion are equal. In this case, it must be a mixture to be a solution, and the compounds that are dissolved can be either polar covalent or salts. Recall that any solution that is in water, the product of the hydrogen times the hydroxide is always 10 to the negative 14. What can we do with this knowledge? I can ask some simple questions like this. So what is the hydrogen ion concentration in each of the following aqueous solutions? Number 1, water. Honestly, this is not an aqueous solution. Because it's water, it's not a mixture and therefore not a solution. But the answer will still be the same. In this case, this is pure water, and we know that in pure water, the hydrogen ion concentration is 10 to the negative 7. We also know that the hydroxide ion concentration is 10 to the negative 7 because this is pure water. How about number 2? We have a 0.00001 molar NaCl solution. The first thing you need to do in these types of problems when we're trying to find the hydrogen ion concentration is decide, is it an acid, a base, or neutral? In this case, we see that this is a salt, and salts are neutral. And since this is a neutral salt, that means that the hydrogen ion concentration is equal to the hydroxide ion concentration, and the answer is 10 to the negative 7 molar. And our last one here, we have sugar, and this is 0.0001 molar C6H12O6, And what we see for this, again, is this is a neutral substance. In this case, it's polar covalent, but it is still neutral, and that means the hydrogen ion concentration and the hydroxide ion concentration are both 10 to the negative 7. And so as you can see, these problems, when we have water, a salt, or a covalent compound that are dissolved in water, we find that the hydrogen ion concentration for any of those solutions is always 10 to the negative 7. Next, we're going to look at acids and bases and see how those are different from neutral solutions.